In my last video, I talked about general ideas that you can keep in mind when trying to find the domain of a function algebraically. But in today's video, I wanted to go over an example of how to actually apply these methods. And specifically, we're going to be talking about how to find the domain of a function that has a fourth root and how this can be applied to finding the domain of a function with any even root, because the process is going to be basically the same whether it's a square root, fourth root, or any other even root. So by the end of this video, you should be feeling a lot better about these types of problems, so you can go ace that domain question that's coming up on your next test. Anyway, be sure to stick around to the end of the video, and let's go ahead and jump right into it. We want to find the domain of this function. Our function is f of x equals the fourth root, so we have an even root here, of x squared plus 3x. Okay, so like I said, the three things we want to look out for: no dividing by 0, no taking the even root of a negative number, no taking a logarithm of a negative or 0. In this case, we do not have any fractions, so there's never going to be a point where we're dividing by 0, because we're not dividing by anything at all in this function. There's no logarithms, so we don't have to worry about taking the log or natural log of a negative number or 0, so that's not going to cause us any issues. But we do have an even root. We have a fourth root here. So what we need to keep in mind is whatever we're taking the fourth root of, we can't take an even root of a negative number. So we need to make sure that whatever we're taking the fourth root of, in other words, whatever is underneath this fourth root here, this can't be negative. Well, how do you actually represent that algebraically? All you have to do is say whatever the thing is that has a restriction on it. In this case, we need to make sure x squared plus 3x has a specific value. We would just be able to say x squared plus 3x. Okay, so we need to make sure basically that whatever is under the square root here has to be 0 or positive, which means it has to be greater than or equal to 0. So you're essentially just kind of setting up some sort of inequality and then solving that inequality for x. So now that we've got our inequality set up, we should be able to basically just kind of solve this for x, and that should tell us basically what x values are okay. So to solve this, probably the best way to do that would be to factor this out. So we could, both of these terms here, x squared and 3x, they both have an x in common, so we could pull x out of it. If we take x out of an x squared term, it would be left with x, or in other words, x squared divided by x leaves us with x. And then if we pull x out of 3x, it leaves us with 3, or 3x divided by x gives us 3. So now we know this whole thing has to be greater than or equal to 0. Okay, so from here, probably the best thing to do, there's, I guess, kind of two ways to think about this. The easier way, the way that I would definitely recommend you thinking about something like this, if you have two factors like this, right? This equation is just x times x squared plus 3. We have these two factors. Think about multiplying two numbers together and how they relate to 0. In order for the product of these two numbers to be greater than or equal to 0, we need one of two things to happen. Either they both have to be positive, or they both have to be negative. If they're both negative, we would get a negative number times a negative number, which is a positive. If they're both positive, we would get a positive number times a positive number, which is also positive. If one of them is negative and one of them is positive, then they're going to multiply into a negative number, which is less than 0. It is also okay for this whole thing to equal 0. So if either of these factors equals 0, that's also okay, but we'll deal with that in a second. So let's just think about what are the cases where we end up with basically both of these factors being negative or both of them being positive. So in order for both of them to be negative, we would need x to be less than 0, and we would need x plus 3 to be less than 0. In order for both of them to be positive, we would need x to be greater than 0 and x plus 3 to be greater than 0. Okay, so now kind of solving these other inequalities, these simpler inequalities, x less than 0 already works. That's already solved for. We already know x is less than 0. For this one, we would just have to subtract 3 from both sides, giving us x less than negative 3. Okay, so basically we would need both of these inequalities to be true, This one, x being less than 0, doesn't really add any new information, because if x is less than -3, it would also be less than 0, right? Like -4, for example, it is less than -3. Obviously, it's also less than 0. So basically, as long as x is less than -3, both of these factors would be negative, and we would multiply two negatives together, giving us a positive number, which is greater than or equal to 0. So this one doesn't really tell us anything new. As long as we maintain x being less than -3, we should be good. Over here, x being greater than 0 is already solved for. This one, we could subtract 3 from both sides, giving us x has to be greater than -3. Okay, and now over here, it's kind of the opposite situation. Both of these inequalities here to be true. If x is greater than 0, it's obviously going to be greater than -3. Like 1, for example, is greater than 0. It's definitely greater than -3. So this doesn't really add any new information. As long as x is greater than 0, this factor will be positive, this factor will be positive. Positive times positive is positive, which is greater than 0. So basically, if both of these inequalities here are true, then this one will be true. Or I'm sorry, if either of these inequalities is true. As long as we pick an x that's less than -3, we will get a positive number from multiplying x times x plus 3. If x is greater than 0, we'll also get a positive number from multiplying x times x plus 3. We can, however, have either of these factors be 0. So I guess technically what we could have done, just kind of going back, we could also say, or not going back, let's take that separate. It's okay if x is 0 or if x plus 3 is 0, because if you get 0 times any other number, it results in 0. So if either of these factors equals 0, 0 times any number is 0. So that means the whole thing will be 0. So if x equals 0, that will also be fine. If x plus 3 is 0, that will also be fine. Whoops. So if we minus 3 from both sides, that gives us x equals -3. So if x equals 0 or if x equals -3, this inequality right here still holds up to be true. So really, as long as x is less than or equal to -3, we should be good. As long as x is greater than or equal to 0, we should be good, because 0 and -3 are also acceptable x values to make sure this works. So as long as x is within one of these two intervals here, we'll be taking the even root of a positive number or 0, which means this function will actually return some output, and we should be good. So basically, that tells us these two intervals. So there's a couple different ways that you can write the answer of one of these problems, the domain of a function. If it specifically asks you to write it in interval notation, we will have to do that. So what this notation here is, the domain of our function x greater than or equal to 0 or x less than or equal to -3. This is another way that you can write the domain of our function. If we need it in interval notation, though, there's another way to just kind of reframe this. Basically, if x is greater than or equal to 0, we would say x, or we would say a square bracket 0 to infinity with a round parenthesis. So what this interval notation is saying is any x value between 0 and infinity, or in other words, any x value bigger than 0 is going to be good, is going to be included in our domain. The fact that we have a square bracket right here, that tells us that this endpoint is included in our domain. So since it's greater than or equal to 0, we need a square bracket here. If we just had x greater than 0, this would need to be a round parenthesis instead of a square bracket. So the square bracket is for equal to, the round parenthesis is for just less than or greater than. If you ever go up to infinity or down to -infinity, that will always be a round parenthesis, because infinity is not an actual number that you can plug in or include in a domain. So that's always going to be a round parenthesis. So then this interval here would be written as x less than or equal to -3. So you typically want to write it from the smallest x number up to the biggest. So 0, infinity. And then this other one down here is going to be from -infinity up to -3, with -3 a square bracket, because -3 is okay. The -infinity will be a round parenthesis. And then what we wanted to do is put like a capital U. It's called a union sign. Basically, the domain of our function is going to be the union of these two intervals. So in other words, any x value within this interval or this interval will be included in our domain. So this would be kind of the final answer for this one. Now, I think that was a great example for you to see, but there's a more general strategy that you can use when finding the domain of any kind of function, not just the kind that we just went over in this video. And I think that's going to be a really important topic for you to understand next. So go click on that video right there, and we'll keep talking about domains of functions in a more broad way that's going to help you with a lot of other types of problems too.